Hello again! In this video, we're going to perform end-of-distribution imputation with Feature Engine. In order to do this, we need to import Feature Engine missing data imputers as MDI. Then we load a mixture of numerical and categorical variables from the house prices dataset. We separate the data into train and tests. And now we create the EndTailImputer, calling the EndTailImputer from Feature Engine. EndTailImputer takes a few parameters that we need to provide. The first one, if you remember from previous videos, we can find where to place the number that we want to use to impute the data using the Gaussian approximation. This is the mean plus minus a number of times the standard deviation, or the inter-quartile range proximity rule, which is the 25th or 75th quantile plus or minus a number of times the inter-quartile range. So here we need to indicate in the distribution if we want to use the Gaussian approximation or if we want to use the inter-quartile range. If we want to use the inter-quartile range instead of Gaussian, we need to pass skewed. Then we need to indicate if we want to place the missing data at the right tail or at the left tail. And there is one more parameter, which is the fold, that by default is 3, but we can also change it. This is the number of times that we are going to add the standard deviation to the mean, if it is Gaussian, or the number of times for which we are going to multiply the inter-quartile range, if it was the inter-quartile range proximity rule. Okay, so in this case, we want to find the numbers using the Gaussian approximation. We're going to put the missing data at the right tail, and we're going to multiply the mean, the standard deviation by 3. If we don't pass the variable's argument to the imputer, this imputer will automatically find all the numerical variables in the dataset, and they will be stored in the variables attribute. We fit the imputer to the train set, and when we do so, it will learn the numbers that it needs to use to replace the missing data. With transform, we replace missing data in the train set, and the transformer returns a pandas data frame. In this cell, I create an alternative transformer just to show you the functionality. So in the distribution, I use skewed, which means that the values that we're going to use to impute the variables are going to be found using the inter-quartile range. And this time, they're going to be placed at the left tail of the distribution. And here I also indicate a set of variables that we wish to impute with these numbers. Then we fit the transformer to the train set. The variables are stored in the variables attribute, and here the transformer learns the numbers that it's going to use to replace missing data in each of these two variables. And we transform the dataset, that is, we remove or we replace the missing data. We can also assemble the transformers within a scikit-learn pipeline. In the first line of code, we create one end-of-tail-imputer in which we are going to use the inter-quartile range proximity rule and place the values on the right for these two variables. And in the second line, we're going to create an imputer that is going to find the values using the Gaussian approximation, placing the values at the right tail just for the variable load from age. We fit the pipeline to the train set. We can navigate the steps within the pipeline to find out the parameters that the transformer learned and that is going to use for the imputation. And then with transform, we can transform our datasets. So that is all for this video. See you in the next one.